Session 88. Apex Triggers. This session covers what triggers are, when they fire, the context variables, the order of execution, bulkification, and how to structure triggers so they stay maintainable over time. If you have written a trigger that works in Sandbox but fails in production, this session explains why. An Apex trigger is code that executes automatically before or after a DML operation on a Salesforce record. DML operations include insert, update, delete, and undelete. The trigger code runs on the Salesforce platform. It has access to the full Apex language, all of your data, and all of Salesforce's APIs. Triggers fire in two phases, before and after. A before trigger fires before the record is saved to the database. This is where you modify field values on the records being processed. An after trigger fires after the record is committed. This is where you query related data and perform additional DML on other records. Trigger.new is the list of records being inserted or updated in the current transaction. Trigger.old is the list of records in their prior state, available on update and delete operations. Both are lists, not single records. Even when only one record is being modified, the trigger receives a list. Additional context variables, trigger.newMap and trigger.oldMap, give you the same data in map form, ID to subject, which is useful when you need to look up specific records by ID. Trigger.isInsert, trigger.isUpdate, trigger.isDelete, triggered.isUndelete, trigger.isBefore, trigger.isAfter. Use these to route logic to the correct path in a single multi-operation trigger. The order of Salesforce record save operations. 1. System validation. 2. Apex before triggers. 3. Custom validation rules. 4. Duplicate rules. 5. Salesforce saves record. 6. Apex after triggers. 7. Assignment rules. 8. Auto response rules. 9. Workflow rules. 10. Escalation rules. 11. Flows and processes. 12. Roll-up summary fields update. 13. Criteria-based sharing. 14. Apex before triggers on parent records for roll-ups. The order matters when you have multiple automations. Flow runs after triggers by default. If your trigger depends on a flow having run first, that logic will not work. Governor limits govern everything that runs on the Salesforce platform. Per transaction, 100 SOQL queries, 150 DML statements, 50,000 records retrieved by SOQL. These limits apply to the entire transaction, not just your trigger. If your trigger runs inside a context that already used 80 SOQL queries, you have 20 left. The most common trigger failure, writing a query or DML inside a loop. 200 records times one query, each equals 200 queries equals governor limit exceeded. Bulkification is writing Apex that handles a collection of records with the same number of queries and DML operations regardless of how many records are in the collection. This is the most important practice in Apex trigger development. A non-bulkified trigger for each record in trigger.new, query for the parent, and update it. That is one SOQL query per record. Pass the limit at 100 records. The correct bulkified pattern. Step 1. Collect the IDs you need from trigger.new into a set. Step 2. Execute one SOQL query outside the loop, retrieving all relevant records at once. Step 3. Build a map from the query results. Step 4. Loop through trigger.new, referencing the map to get related data. Step 5. Collect the records you need to update into a list. Step 6. Execute one DML statement on the entire list. One SOQL query. One DML statement. Handles one record or 200 records identically. The single trigger per object pattern. You should have one trigger per Salesforce object. Inside that trigger, you call handler classes to process the logic for each operation type. Do not write multiple triggers on the same object. The order they execute in is not guaranteed, and managing them separately becomes a debugging nightmare. The handler pattern in practice. Your trigger file calls a handler class method for each operation, before insert, before update, after update, etc. The handler class contains the actual business logic in separate methods. This keeps the trigger file clean, typically 20 to 30 lines, and makes the logic testable in isolation. Example trigger structure. Trigger account trigger on account, before insert, before update, after update. Account trigger handler equals new account trigger handler. If trigger.isBefore. If trigger.isInsert, handler.on before insert, trigger.new. If trigger.isUpdate, handler.on before update, trigger.new, trigger.oldMap. If trigger.is after. If trigger.is insert. Handler.on after insert. Trigger.new. If trigger.is update. Handler.on after update. Trigger.new. Trigger.oldMap. The handler class methods receive the context data and handle the logic. Testable, maintainable, readable. Recursion is a common trigger issue. Trigger fires on an update logic modifies a field. Trigger fires again infinite loop or unexpected behavior. The common solution, a static Boolean variable in a helper class. Set it to true when the trigger fires the first time. Check it at the start of the trigger and return early if it's already true. This prevents the second firing from executing the same logic. Test coverage. Apex requires 75% code coverage before you can deploy to production. This is a minimum, not a target. Write tests that verify actual business logic, not tests that exist to reach the percentage. A test that inserts one record does not verify bulk behavior. Insert 200 records in your test. Verify that the trigger processed all 200 correctly with the expected number of queries. Testing patterns. Use test.startest and test.stoptest to reset governor limits between setup code and the code under test. Test.startest gives you a fresh set of governor limits for the action you're testing. Use system.assert equals to verify the expected results. Test both positive and negative cases. What should happen when the trigger fires correctly, and what should happen when the logic should not fire, e.g., a field that hasn't changed on update. When not to use a trigger. Not every automation needs a trigger. If the logic can be expressed clearly in a record-triggered flow, use flow. Flow is easier to maintain, readable by non-developers, and doesn't require deployment via change set or package. Triggers are necessary when you need external callouts, bulk processing that flow can't handle efficiently, complex exception handling with rollback behavior, or transaction control that declarative tools don't expose. Flow versus trigger for the same use case. A lead record-triggered update that sets a field based on a condition. Flow is the right tool. The same logic that also needs to call an external REST API on insert. Trigger with an invocable method for the callout, or a trigger for the callout directly, noting that HTTP callouts must be asynchronous in triggers. The async requirement. Triggers cannot make synchronous HTTP callouts. If you need a callout in a trigger context, use a future method, a queuable, or an invocable method marked with allow callouts. The @future annotation. If you need to perform a callout from a trigger context, mark the method @future callout equals true. This runs the code asynchronously after the transaction completes. Limitation. Future methods do not support subject parameters. Pass IDs and query the records inside the future method. For more complex async work, Queuable Apex gives you chaining, larger heap limits, and the ability to monitor jobs in the Apex Jobs UI. Batch Apex handles high-volume operations that exceed single transaction governor limits. Deployment checklist before pushing a trigger to production. 1 trigger per object. Handler class pattern implemented. 75% plus test coverage with meaningful assertions. Bulk test with 200 records. No DML or SOQL inside loops. Before versus after phase used correctly. Recursion prevention if needed. Error handling with try-catch for critical sections. All sandbox and regression tests passing. Do not push Apex to production that you haven't tested against bulk scenarios in a sandbox. Summary. Apex triggers fire before and after DML operations on Salesforce records. Context variables, trigger.new, trigger.old, trigger.isInsert, etc. give you access to the data in context. Bulkification is mandatory. Collect IDs, query once, build a map, single DML. 1 trigger per object with a handler class. 75% plus meaningful test coverage. Use flow for declarative safe scenarios. Triggers for what flow cannot handle. Session 89 next. Salesforce profiles versus permission sets. Which model belongs in 2026? Full session at realsyllabus.com.